Hello, my name is Fahri Aziz from TI 23I. I will explain about material in session 1 until session 7 in algorithm and data structure. Session 1 is basic concept of algorithm and introduction to algorithm. So, first, uh, what's the meaning of algorithm? Algorithm is a logical sequence of commands to solve a problem. And how how to representation algorithm is with pseudocode, flowchart, and description. Uh, Character on the computer keyboard will be recognized using an ASCII code, which will be converted into a binary number. ASCII is abbreviated from American Standard Code for Information Interchange. Is a character encoding standard for electronic communication. ASCII code represents text in computer, telecommunication equipment, and other devices. And algorithm representation is with description. Description is just like you describe about something like cooking a noodle, like this. And flowchart, like chart chart, yes, with yes, chart with start and rows, input or output, process and decision. And last is pseudocode. Pseudocode is a way to write algorithm that resemble programming language with some convention, like read, input, output, process, initialize, and process. Yes. And in session 2 we will explain about efficiency. Efficiency in the context of algorithm refers to the ability of an algorithm to complete task or solve problem using minimal resource. The two main aspects of algorithm efficiency are time or time complexity. It measures how quickly an algorithm can complete its task. This involves analyzing how many steps or operation the algorithm requires as a function of its input size. Space space complexity. It measures how much memory of space algorithm needs to complete let its task. This involves analyzing how much memory allocation to the algorithm request as a function of its input size. And efficiency is crucial because limited resource, application performance, and cost scalability. In software development or computational problem solving, choosing or designing efficient algorithm is a key to achieving optimal performance. And in session 3 we study about stack data structure. Stack is a fundamental data structure in computer science that follow the last in, first out or LIFO principle. Here's an explanation of the stack data structure. Definition: stack is a collection of elements with two main principal operations, push and pop. Push is adds an element to the collection, and pop is remove the most recently added element that was not yet removed. And characteristic in data stack is last in, first out or LIFO. The last element added to the stack is the first one to be removed. Think of like a stack of plate. The last plate you put on the stack is the first one you take off. 2. Operation: push or pop adds element, yes, like before. Pick or top is retrieve the top element without removing it. It's a way to look at the element that will be popped next. In real life analogy, just think of a stack as a stack of books. You add a book to the top of the stack, push, and you take the top of book of the stack, pop. You can only interact with the top book without disturbing the rest of stack. Use case is function call management. The call stack in a programming language is stack used to manage function calls. When a function is called, its information is pushed into the stack. When the function complete, information is popped off the stack. Implementation is a stack can be implemented using arrays or linked lists. The key is the maintain in the order for elements such that the last element added is always at the top. In the summary, in essence, a stack is simple and powerful data structure with a narrow, well-defined interface is LIFO. Nature make it suitable for various applications where the order of processing or the ability to quickly access the most recently added element is crucial. And in session 4, we study about QW data structure. QW is a fundamental data structure in computer science that follow the first in, first out, or FIFO. And the characteristic is, yes, first in, first out, FIFO. The first element added to the QW is the first one to be removed. It's like a line or queue of people waiting for a service. The person who arrives first gets served first. Operation is NQW then NDQW. Adds an element to the rear of the QA, removes the element from the front of the QA is DQW. It is front and rear or head and tail. Front is the end of the queue from which element are dequeued, and rear the end of the queue to which element are unqueued. In real life analogy, think of a queue as a line of people waiting to buy ticket. The person at the front of the line is the first to get the ticket or the queue, and new people join the line at the near or end queue. You can only interact with the person at the front of the line. Implementation, a queue can be implemented using array or linked list. The key is to maintain the order of element so that the element at the front is the oldest and the one at the rear is the newest. In summary, a queue is versatile data structure that find application in scenario where element must be processed in a specific order, and the first element added is the first to be processed. The FIFO nature of queues make them suitable for modeling real-world scenario where fairness or chronological order is important. In session 5, we study about linked list. Linked list is a linear data structure where elements are stored in nodes, and each node points to the next node in the sequence. Unlike arrays, linked lists do not have a fixed size in a memory and allow for efficient insertion or removal of elements at any position within the list. Here is an explanation of the linked list data structure. One is a key component, like node, head, tail, and tail. Yes, node is a fundamental building block of linked list. It contains two files, data and next or link or pointer, 2 head, 3 tail, or in doubly linked list. Next is type of linked list: singly linked list, doubly linked list, and circular linked list. In operation, one is insertion. Element can be efficiently inserted at the beginning, middle, or end of linked list by updating the pointer of adjacent nodes. 2 is deletion. Nodes can be easily removed from a linked list by updating a pointer, making it efficient for dynamic resizing. 3 is traversal. Linked lists are traversal by starting at the head and moving from one node to the next until the end of list reached. In summary, linked list is a flexible and dynamic data structure that allows for efficient insertion and deletion of element at any position. Its design make it particularly useful in situations where the size of data structure needs to change frequently or where quick insertion and deletion are critical. And in session 6 we explain about collection. The term collection in computer science generally refers to a grouping or containers for data elements. Collections are used to organize and manage groups of related that in structured and efficient manner. There are various types of collection, each designed for specific use case and requirement, like array, lists, sets, maps, queues, stack, collection framework in Java. Benefit the collection provide a way to manage and manipulate groups of data efficiently. They offer different trade-off in terms of access time, memory use, and other factors, allowing developers to choose the right collection type for specific tasks. In summary, computer science collection is a term encompassing various data structure designed to organize, store, and manipulate groups of related data elements. The choice of particular collection type depends on the specific requirement and characteristic of the data and the operation to be performed on it. And in the last session is list. We will explain about list. List is ordered collection of elements. Lists are fundamental data structure that allow for the storage and manipulation data in sequential manner. The key characteristics of lists include their ordered nature, dynamic size, and flexibility. There are different types of lists. One is array lists, linked lists, doubly linked lists, circular linked lists, and array. Key operation of list is insertion, deletion, traversal, and search. Benefit in list is provide a flexible way to organize and manage data in structured manner, and they can be easily resized, making them suitable for scenario where the size of the data set is not known in advance. In summary, a list is a versatile and fundamental data structure used to organize and manipulate ordered collection of elements. The specific types of lists chosen depends on the requirement of the task at hand, and the operation is the need to be performed on the data. Lists play a crucial role in various programming scenarios and are widely used in software development. Okay, that's it. Thank you.